went through on the 1.75". We went through 5 prototypes. I suck at spelling. Prototypes, right? We went through 5 prototypes, and a loom at a hose factory is like a mining truck, right? You go to a big mine, those things have a duty cycle of 24 hours a day. A dude gets out of it, another guy shows up with his lunchbox and gets in it and like drives around because they want it making money, right? It's that loom's designed to print money. It just like, so when we asked, and I went to all hose companies like 4 years ago, hey, I have this idea, this is what I want to go back. Everyone's going to 50 PSI, everyone's going back to a high GPM, low nozzle pressure. Well, what's another name for nozzle pressure? What really is nozzle pressure?
Reaction force.
What is it really? It's back pressure.
Back pressure.
Right?
Yeah.
So when you look at like a traditional 200, when you look at a traditional 200 feet cross lay, right? And you're down here at 50 PSI, right? And you're down here at 100 PSI, right? Well, if you look at friction loss, if you look at like 150 PSI, 150 GPM, right? 1.75 inches, and let's just call it 30 PSI per 100, and here in the middle, right? So the first 100's 30 PSI plus the nozzle pressure, right? So what friction, how much pressure do we have right here? Well, here we have 80 PSI, right? And here we have 130, right? Back here at the pump panel, we have 110, and here we have 160. And down here, right at the nozzle, we only have 50, and here at the 100 PSI, we have 100. But we're still flowing the same gallonage, right? So in the last 3 feet where we get nozzle whip, right, this hose has an extra 50 pounds per square inch holding it open. So which hose can be inherently lighter weight and have less spine to it? So the high nozzle pressure allowed hose design to become what? Lighter weight, right? So now, but here's the issue, this 100 PSI nozzle is 75 pounds nozzle reaction, right, at 150 gallons a minute. Here, we're at about 55 pounds nozzle reaction.
Nozzles get dropped, right?
Same gallonage, much less nozzle reaction, and the UL study just showed an open flowing nozzle, right, is a very safe nozzle, and even every hit and move attack we did in the UL study showed temperature rebound. So any gas shielded fire, any hallway you're going down, the longer the nozzle's open, the better, right, straight and solid. So there's a huge advantage to this, but if you own hose that was designed to work with 100 PSI nozzle back pressure and you're trying to map the way down, right, this hose becomes difficult to keep the line open because the nozzle's trying to hit you in the face because it was really designed to work with 100 PSI nozzle pressure. One of the owners of a West Coast hose company, one of the first hose companies I was involved with, was very angry. He said, I don't know why the nozzle manufacturers didn't inform us that they were going to go back to a low pressure, because I would have changed my design years ago, right? And I'm like, well, it was physics. It wasn't the nozzle companies. It was the customer saying we're moving back this direction. So TRUID is a product made by Key that me and some friends were involved in making the concept. True hose is a concept driven by the consumer, right? Us. So when we made the 5 prototypes, right? Each time we learned something. Well, there was only these 3 coupling bowls that we could use commercially available.
2 3/16, 2 1/8, 2 1/4.
This 2 1/4 one was basically made for New York City, because New York City did 1.88 inch hose, and so they had polyester outer jacket, polyester inner jacket, nice thick rubber jacket, same over here on the other side, and if you measure the internal size, it comes 1.88. If you times If you divide 1.88 in half, you get about 15 sixteenths. 15 sixteenths is half the diameter of this
I always miss the good stuff.
hose, right? That
It's
meets
always
the
stuff.
Freeman principle of the smoothbore tip design that Freeman designed in the late 1800s. If you go half the diameter of the hose, you get 21 feet per second in the hose. Fast water means it washes the kinks out, right? So that's why 1.88-inch hose existed. It was basically designed and made by New York City. Now everyone says FDNY spec was made by Key. It wasn't always made by Key. It's a spec that they designed, and it's been made by a lot of different companies over the years. Like a lot of the Warrior hose was made by Pond. All these companies that are owned by All American, they used to be small family-run companies like National Hose, Pond. Those were all small family companies. Now, so this 2 1/4-inch coupling, synthetic material is about 3 times stronger than natural material. So like if I take a cotton rope, like a hemp rope, or a manila, grade 1 manila rope, 1/2-inch rope, it's about a third less as strong than synthetic. Same thing occurred in the hose industry. So as synthetic material got stronger and they moved away from cotton, right? In 2 1/2-inch hose, the coupling bowl, the standard coupling bowl is 3 inches, right? And cotton used to be basically there was a 1/4 inch of material over here, cotton and some rubber, and a 1/4 inch over here. What's a quarter plus a quarter? And then if you take a half and you minus from the 3 inches, you get 2 1/2. So as they got to synthetic material, the reason this is 2 3/4, right, is because the synthetic material was so much stronger. They could remove a lot of the material. They never changed the coupling bowl size. So you'll notice, like in the TRUID 2 1/2, it's not a 3-inch coupling bowl. So we started in this. Rubber's the heaviest thing in the hose. So as I added more rubber to try to shrink down this diameter back to 1 3/4, because I'm a big fan of the 160 GPM flow. If you try to flow 160 GPM in 1.8-inch hose, what happens to the velocity of the water in it? It goes down, right? So we looked at this. Well, I wanted a nice heavy duty hose, so we looked at the synthetic material, and I wanted a rubber thickness of like 3500ths, 4500ths. Now, when you extrude the rubber, there's a tolerance, right, in the extruder. I wish the NFPA would allow the tolerance to split the middle of the hose, right? Because right now, a hose manufacturer can sell 1.75-inch hose, but they can't. None of it can be smaller. It can't be 1.73, right? So if the tolerance is, let's say, 500ths up, 500ths down, right? Everything has to be 5,000ths up, 500,000ths down. That means 200ths has to be up, because they'll violate the standard if any of it's below. So that means, like, for example, TRUID, they're selling it as 1.75-inch hose, but the full tolerance error has to be above. So it's probably more like none of it's below 1.75, but it might be as big as 1.76, or maybe some of it's 1.77, right? So depending on the extruder, there's a tolerance in the machinery, right? All hose manufacturers. So he asked, like, why doesn't it lay flatter? Well, here's something interesting about hose, right? So back here to this 50 psi and 100 psi, right? This last 3 feet of hose, right? that we're all concerned with nozzle width, right? Right? Here at 100 psi, I can make the hose very lightweight because I have a lot of hydraulic force holding it open. Here, right, I'm going to have to pay a lot of attention to detail the way the hose is constructed, right? Because I've sacrificed back pressure to gain less nozzle reaction. But I still have, like, let's say this is a good 60 to 70 feet of reach, and this is a good 50 feet of reach. So I still have plenty of reach to work in a residential compartmentized building. So I don't need any more reach. I really want to be able to open and flow the nozzle. So here I'm willing to sacrifice some lay flat, right, to get to this. Now, how are we going to do this? Well, we did some weave changes on the inner jacket to get it to stiffen up. Some companies, like a lot of people like Pond Conquest, it's through the weave TPU, right? So it's plastic, so it's a little bit stiffer. You know, other companies use a TPU. There are options, right? There are options to stiffen this up. So we went double jacketed rubber line. We thickened up the rubber liner, and we did some alterations to the weave. Now, we had to end up adding a little more rubber, right, to get it close to 1.75. More rubber than I would have liked. I personally would have loved there to be a 2 3/32 coupling bolt, right? But, right, it would have been like somebody, like, you can give someone like a nice bottle of Cabernet from Napa Valley, or you could get somebody a bottle of like Chateau Lafite, like 1965, and it's like $2,000 a bottle versus $80 a bottle, and probably there's only a few people that are going to be able to tell the difference, right? Right. So you're chasing the dragon, right? And what I wanted to do, I was working with departments that weren't ordering, 3,000 feet of hose. I was working for departments that were ordering 100,000 feet of hose, right? So I needed to keep the price as low as possible, right? So like I was shooting for $150 a length or less, like $145 a length or less. The department that ended up buying this was buying $1 million worth of hose that year when we were shopping around. They were buying hose for 30 rigs. They were replacing all the hose in the department, supplying everything. So I was able to go to hose manufacturers and say, hey, this is what I want made. A lot of hose manufacturers said, we're not going to do that. We're not going to make a one-off hose. And I'm like, this isn't going to be a one-off hose. I think it's going to be a popular product, right? So, and eventually it's become a popular product. Now, this gentleman here said it doesn't lay as flat, okay, which is true. And one of the ways you can overcome it is roll it tight and load it from a roll between your legs. And I can send you a video of it, and then put your strap on it, okay? Yeah. And I honestly think that's a really good way. If you're in a Minuteman load anyway, I think that's a really good way to load hose.
Which hose is it?
But that's the hose, TRUID. But honestly, if you're in Pond Conquest, which is very stiff hose, if you're going to be in a low pressure, whether it's combat ready from Key, Pond Conquest, right, or other anti-kink hose that is of substantial weight. If you go and read Andrew St. James Fire Engineer article about burn through, right, there's a wooden table there, right? Let's just talk about physics here for a second. If I double the material mass of the table, if I take it from, let's say the table weighs 20 pounds of material, and I just double the material in it, just proportionally. Now it's a 40-pound table. Which one's going to hold more weight? The 40-pound table, right? So it's just the way. Which one's going to be more durable? The Elkhart nozzle, right? It's probably one of the best nozzles on the market, but it's one of the ones that's a little bit heavier. So some guys have complained, but it's more durable. You can't get something for nothing.
They're going to complain about something.
Yeah, they're always going to complain about something. So when I was designing the hose, my target weight was honestly between 19 and 21 pounds, and it ended up being about 22 pounds. Well, if I had a 2 3/32 coupling bolt, right, I probably instead of needing 4500s, I could have maybe been 3500s. Rubber's the heaviest thing on the hose. So maybe 3 years from now, that will be changed. Maybe, you know, but the cool thing about that is the pump chart will remain the same because the internal diameter will stay the same, and then it won't change anything. The problem is, about 7 years ago now, God, I can't believe it's been that long, the National Fire Protection Association's research division did a friction loss study that showed all the pump charts were wrong in America. Well, the NFPA rule said you cannot sell a hose that's smaller than what's marked on the jacket, but you can sell a hose that's larger, right? So there's a very popular hose in America that's sold as 1 3/4 inch, and it's really basically 2-inch hose, right? So it's like totally different. Water's the heaviest thing, right? And so there's a lot of people flowing 125 to 150 gallons a minute, just pulling 2-inch hose around for no particular reason, and then the water's traveling really slow through that hose. So back to this. So then people go, why does TRUID 2.5 lay flat so well? Well, we didn't have to manipulate the inner jacket as much because. Well, let's think about this. What's when you figure the area of a circle, right? Pi r squared, right? There's an exponent, right? So that means that means
I want to own that.
That's your new tattoo.
That's your new tattoo.
Yeah. That means that in 2.5-inch hose, that last 3 feet has what? More square inches in it, right? Significantly more square inches in it. So let's go back. I always have to relate stuff back to trucks, right? So like, at the same air pressure, right? Let's say you're lifting something with an airbag, and an airbag has a 10 by 10 contact match. So there's only 100 square inches, and you have 50 psi on the airbag. How much can you lift up? So it's 50 psi, and you have a 10 by 10 contact. So 10 times 10 is what, 100? And 100 times 50 is 5,000. So that would be 5,000 pounds, right? 2.5 tons.
Yeah, we all knew that.
Yeah, oh, for sure.
Well, so that little 10 by 10
What's an
airbag can lift,
I left him like this, like an hour.
right, 2.5 tons. Well, I can take that next airbag size up, right? And let's say instead of 10 by 10, I just go 20 by 20. It's just a square that's twice as big, but now 20 by 20 is what? 400 square inches, right? 400 square inches times 50 is what? 20,000. 20,000 what is 10 tons, right? So that 2.5 has a lot more square inches in it, right? So that same 50-pound back pressure and 2.5, right? Has anyone ever had a problem with nozzle whipping 2.5, even lightweight stuff?
Well,
Very, not as much though. Very less, because there's more surface area. So that 50-pound square inches it's acting on more surface area, so it's more hydraulically dynamic, holding it open. So a 2.5-inch hose, you don't have to pay as much attention to its stiffness. So let's think of it this another way, right? If you were gonna bend a piece of conduit, right? You're an electrician, and you're gonna come in and pull wire all day. Would you want to oversize the pipe for no particular reason? Like you're gonna bend EMT, and you say like, I could do this whole run in 3/4, or I'm gonna do it in 1 inch, right? You want to do it in 1 inch because it's a pain in the ass. It's harder work, right? So the 2.5 can be a little less, have less of a backbone because there's more hydraulic force holding it open because the surface area is more on the back. So people go like, why is TRUID 2.5 lay flatter, right? We were able to make the pick count and some of the way it's weaved focused on laying flat. Why would I want 2.5 to lay flatter? But why, as a firefighting professional, when I designed it, it was just like, I want this to lay flat, and I'm going to sacrifice some of it. Where's 2.5 always going to be used?
It's gonna be like
High rise. Right.
For
Because
hose pads.
so if I want my 1 3/4 to be 18 to 22 pounds because I want it to be materially heavy. Let's go back to Adam St. John's research. If you go look at that fire engineering article and you look down on the chart, the 2 hoses that did the best, right? They all failed. By the way, that Boston Back Bay fire, steel would have fucking burned through. All right, and if you look at the research, the prototype Kevlar hose that they were testing was one of the first ones to fail. Okay, it's in the flow path. It's you transition from high to low. It's in the chimney, right? So it's 2,000 degrees in that. When they went to look for the hose after that, there was an entire section that was vaporized. They couldn't find it, right? And frankly, I probably would have died the same way. You know what I mean? They went down in the basement. That's like the dominoes thing. There's a lot of people second guessing that, and it was heavily wind impacted fire. Then like we're looking at the fire dynamics of it, and like someone's like, well, if somebody had shut the front door or cut the bottom 12 inches off the door and shut the front door, right now you don't have an exit. It's like, yeah, that's hindsight stuff, and it's cool stuff out of the research, but it's nothing that normal people would have thought of on scene. It's practical now. We should be talking about it.
Now that we've had
But
years to look at it.
but it's not practical then. But if you go back and look at that article, all the hose that had significant weight to it was the stuff that like Angus Premier in the chart and Key Combat Ready. So were the 2 that lasted like 30 seconds longer than ever. And the light stuff, the stuff that was all under like 15 pounds was the stuff that failed this thing. It's just like the fucking table. The 40-pound stuff's gonna last a little bit longer, but all of it failed within like 30 seconds. If you expose it to that kind of radiant heat, now doesn't matter what it's gonna be. Now here's the interesting thing, right? The melt point of polyester and these synthetic materials is all between 400 and 500 degrees. Right? When they extrude it out of a machine to make this. But before you get to the melt point, it weakens, right? So what is the hose really doing? Is it burning through or popping? Because think about it. Even with the nozzle open and flowing, right? The hose is going to last longer with the nozzle open and flowing because when's the hose have the most mechanical force on it? When it's closed, right?
Okay.
Because when the nozzle is closed here, there's 110 pounds pressure on everything, right? Right? Because fluid not in motion in a system exerts equal pressure in all directions.
I thought you meant as far as absorbing the heat,
Right.
and the transition.
What they discovered in the experimentation is that whether the hose is charged, wet, or dry, doesn't matter. They charged it with air. It's all within a cup. It's all within like basically the margin of error. It's all within a few seconds. Maybe a wet charged hose maybe adds a few seconds, but it's not going to be anything that saves anyone's life. What's really gonna save your life on like a basement fire is if you can attack it off plane, on plane instead of off plane. If you can go to the B side or the C side or get it from the D side, you don't have to go down.
The same with water flowing.
Basically, it is. Yeah, yeah. You basically, if I was still on the job in Oakland, I went to a hillside house fire, which I have done, and I've gone on the address side and down the stairs several times. I would change my behavior now. I would show up. I do my incident. I do my on scene. Hey, I got 2 up, 2 down. Fire on the first sub-level 1. If I could go down the B side and go in a man door and just cool that environment and have the next line protect the stairwell and have the search go up, that would be the way I would take care of those fires now. And I wrote that thing on my website about how I think you protect hand lines. It's all about flowing water. It's all about on plane versus off plane. And I don't think there's going to be a solution technologically right now through hose. I think you should buy. My personal belief is you should buy durable hose. 1 3/4 hose should be weighing 18 to 22 pounds coupled per 50 feet. Because of material engineering, there's no unicorn here. There's no magic. Everything has these materials that basically have melt points that are very similar in construction. I talked to a material engineer at UC Berkeley. I went to the Library of Congress. I looked this stuff up. And I think 2.5-inch hose, you should be buying 2.5-inch hose that really, if you want durable hose. Now, they were talking about radiant heat failure. 2.5-inch hose, I think, should really be weighing between 28 and 32 pounds. If you have buildings that are greater than 30 stories and you're routinely hiking up, let's talk. Maybe we can get in the 25-pound range. But the largest fire departments in America that have tall buildings routinely buy hoses that way.
I
They
can't
don't have a
throw.
problem. So, Giants fan. So that's where we're working with. Every hose company's working with the same material. Can you buy good hose from every company? I think you can, and it's a system, right? And then when you spec your pumper, you got to see where your pressure pickups are and everything, because that's the other part of the system. Your gauges have to read accurately for all the stuff to work together. So, I would like to see a 2 and 30 seconds bowl, made, maybe in the future. Some companies are experimenting with smaller bowls. There's a 2-inch coupling bowl now, and someone's making a 15-pound 1 3/4 with a true diameter of 1 3/4. It's a very light 1 3/4. It does have 21 feet per second, but is it going to wear out faster than an 18? Yeah, but let's not talk about thermal and let's not talk about radiant heat. What else fails hose on the fire ground? Direct heat, right? So Colin Kelly wrote that article from Vegas where they went up and it was a hot handrail and they put a very lightweight constructed hose and it just touched the hot handrail and it instantly failed, right? When I teach hose and nozzle classes, and I don't teach hands-on very much anymore. I'm usually like a lead instructor, I have people help. I don't teach, people say, hey, load the corner, push it up into the corner. If I see someone doing that in a class, another instructor doing it, and they say, hey, load the hose in the corner, and it's the fire floor, I'll do it the floor below. I'll let the instructor do that. But if it's a fire floor, I'll never let anyone load hose above about 2 feet on the fire floor. Why?
Is that handle?
It's direct heat. Yeah, I never.
Dennis, they would burst on radiant heat, but on direct heat, they just burn through.
What? It's the same deal. It starts. You put it on something hot, it starts melting the jacket, right?
Yeah.
Eventually, it's going to get to a point where it's heated up the polyester, where it loses its mechanical strength. And once you've lost the mechanical strength, right? Boom, the hose bursts because it's under all its pressure. But when the nozzle's shut, you have 110 psi all the way through. With the nozzle open, right, you have 110 psi. Here you have 80 psi, right? The next one down, you're 15 psi less, right? So what's 15 minus 80? You're at 65, and then down here you're at 50. So as you get away from the rig, the mechanical force that's attacking the hose actually goes down. So you could make a legitimate argument that as the hose line is open and flowing, the hose has less mechanical force attacking it, right? So, these are very nuanced arguments, but I like it's a nuanced argument because it gets me to the point like, hey, an open nozzle has another benefit, right? That your hose. The other nice thing about open nozzle, what's going to happen to these kinks as you pull them? They're going to wash out, right? Here's another interesting thing, right? The 100 psi nozzle, right? The kink's less likely to form, but let's put a kink right here at the middle point, right? And I'll put a kink right here. Which kink's going to occlude more water? The kink with 130 psi or the kink at 80 psi?
130 to low pressure because there's less water there.
What?
I would think the low pressure because there's less water there.
Right. So that some people would think that, and
Same
then
water.
some people said 130. It's the 130 because there's more pounds per square inch holding that kink tight, right?
Just because I read your stuff, bro.
Yeah.
Not 'cause I'm smart.
Right. Now you're both flowing the same 150 gallons a minute. So since there's less pressure holding this kink and there's the same velocity holding it through, it's going to wash out faster too. However, this kink's going to be what? Harder to form because there's no pressure holding it, right? It's a give and take. You can't get something for nothing. So if you make a lightweight hose, if you're like super focused on, I want hose that's under 15 pounds, right? It's gonna wear. If you have Aaron Fields come in, you start clamp sliding all over your drill ground, it's gonna wear out quicker. You know, that's it. So if we just stick to honesty, like, salesmen get away from magic and say, hey, maybe if you buy, I know I'm warrantying this for 10 years, but hey, honestly, if it's 14 pounds, you might want to replace this every 5 years, and you might want to inspect it every 6 months and be a little more diligent. Sure, it meets the pressure standard. Most of NFPA 1961 is strictly a pressure standard, and the direct conduction test, they heat up a block to a certain temperature, they lay it on there, they take it off, and then they do a pressure test, and if it passes that, it's a minimum standard, right? Since there's only a minimum standard, there's no rating. I propose the NFPA. I'm like, I buy a car tire and it comes with a temperature rating, A, B, or C. It comes with a tread weight. Why can't we do that in the fire hose? So if you're a fire chief, I want an A temperature rating, I want a tread weight rating of this. So when I go out to bid, I can say I need an air taper. So it's not a minimum standard. You can go out and there's some qualitative stuff to it. They're telling them what it can do, which they're kind of working on. I'm not part of the process. I'm kind of the asshole in the room.
But part of the solution.
Join the club.
But that's it. That's it. So there's still work to be done, and there is a